In this video, let us see about star-delta transformation. So if you have a network like this and you want to measure the resistance between these 2 points, this point and this point, it is not easy because all the resistance are not in series parallel combination. So in such cases, reducing the network is difficult. So here we can apply star delta transformation to reduce the network and simplify the circuit. So this star delta transformation helps to reduce the complexity of the circuit. Now let us see about the star network first. So this is the star connection. You can see there is a central point or a neutral point from which all the phases are connected. The best example is a three-phase circuit will be connected in star network. So here neutral point will be there in which one end of the phase will be connected. In delta network, it appears to be in the shape of a delta, and you can see here there is no neutral point. So each phase will be connected, the one end of each phase will be connected to other phase. So this is called delta network. The basic difference is this neutral point will be missing in the delta network. Though you can convert one network to the other, this point will be missing in the delta network. We will see the formula to convert from one network to the other network. Let us see about star network. You see all these pictures are star network, but they appear to be different. Actually, all are same. You have to identify the neutral point. From neutral point, if one end of the phases are connected, it is a star network. It is also called Y network because it resembles the shape of Y. So see here, it appears to be T, but from neutral, three phases are connected. So it is a star network. And this is the picture of delta network. So delta doesn't have any neutral point. So three corners will be there, or it will be in the shape of a triangle. So this is also delta network, and the third one is this network. You see here, all three are connected together in a sequence. So this is also delta network. In most of the problems, they may give you like this. This is a delta network. You have to identify that this is a delta network because one end of each phase is connected to the other phase. For example, you take this circuit. Okay. So it appears to be a series parallel circuit. Actually, it is not a series parallel circuit because when the current comes here, it gets divided into two parts. Again, it again divided into various parts. So it is not a series parallel combination. So you can see here one delta is there, here one delta is there. You see this part, lower part. So it appears to be a series parallel circuit. Actually, it is a delta circuit here. Again, this can be connected here. This 8 ohm can be connected here. So you can find it as is a delta network. So when you do some problems, you will understand this one. Now let us see how to convert this star network to its equivalent delta network. Remember one thing, star network can be converted into its equivalent delta, but the resistance in star network will be different from that of what is the resistance in delta network. So you have to find, if you know RA, RB, RC of star network, you have to find what is the value of RAB, RBC and RCA in case of delta network. So there is a direct formula for it. So you can substitute those values and find what is this resistance. So you want to find what is RAB. Okay, because we want delta connection now, you find what is RAB. So to find RAB, you see the terminals A, B. RAB is between A and B terminal. So this is RAB. How to find RAB? So RA into RB, you multiply the adjacent resistance plus RB plus RC plus RC into RA. So you multiply the adjacent arms, okay, and then add those values divided by, if you want to find RAB, you divide by the other variable, that is C. You want to find RAB, so you divide by RC. So in this case you can find what is RAB. There is also derivation for how you are deriving at this one, but I have not derived it because you need only the formulas to solve the problems. So if you learn this one, this is sufficient. And to find RBC, see here it is RBC, which is missing A. So your denominator should have RA. Numerator is same for all the formulas. Okay. So numerator you can find once, just multiply the adjacent arms, add it, divided by whichever value is missing here, you put it here. So for BC, divide by RA, for CA, divide by RB. So in this way, a star network can be converted into delta network. So any arm in delta, so if this is delta network, so any arm, that is any arm resistance is equal to sum of product of two adjacent terms. So product of two adjacent terms, add all those things. So sum of product of two adjacent terms divided by third star resistance. Okay. Now we want to convert delta to star network. So this is delta network. We want this network. So you have to find RA. Suppose if you want to find RA, what you can do is take this terminal A. So what are the adjacent terms? RAB and RAC. So RAB, RAC divided by sum of the resistance. You remember one thing, when you are converting delta to star, denominator will be same in all the three cases. If you want to find RB, multiply the adjacent terms RAB into RBC divided by sum of all the resistance. Okay, so this will be easy. For finding RC, multiply the product of these two divided by sum of the resistance. So any arm of star connection is equal to product of two adjacent terms divided by sum of the arms of delta. So we have learned both the formulas. You remember like that, you will not forget easily. Let us do some problems and learn the star delta conversion. So first problem, the delta network is given and you have to find what is the equivalent star network. Remember one thing, when all the values are equal, either in star network or delta network, the conversion is very easy. Okay. So now delta network is given, you have to find the equivalent star network. Find what is RA. What is RA? This 3 into this 3 divided by sum of all these things. So 3 into 3 divided by 9 equal to 1 ohm. So there is no use in finding RB and RC because all values will be same. Okay. So all are 1 ohms. And you have to remember one thing. This delta is converted into star. So 3 ohms becomes 1 ohms in star connection. So in star the resistance value is getting divided by 3. Okay. So it becomes R by 3. So if you have R here, it becomes R by 3. That is, in this case 3 by 3 equal to 1. So remember, delta is a closed network, resistance will be high. When you are open in star, resistance decreases. Okay. So star means less resistance compared to delta. Now we will see another problem where you have different resistances. So in this case you have to apply the formula. You have to find the equivalent Y network. So find RA. What is RA? 50 into 30 divided by sum of these, that is 100. So sum of these I am finding it separately. 50 plus 30 plus 20 is equal to 100. So RA will be 50 into 30 divided by sum of these. Even though you don't remember the formula, just remember the symbol. So if you want RA, multiply these two divided by sum. So similarly for finding RB, 50 into 20 divided by this sum. RC is 30 into 20 divided by 100. So you will get 15, 10 and 6 ohms. You see all these resistance will be less than the resistance here. So star means open, open means resistance less. Now let us see another problem where you want to convert this star network into equivalent delta network. Now so you want to find what is RAB, that is between these two. So you multiply these two and here. Okay, RA into RB, RB into RC, RC into RA divided by whichever is missing here, RC. Now let us find what is the numerator value because it is common in all. So see, another thing you have to note down here is it is given in 2 kilo ohms. It is not 2 ohms, it is 2 kilo ohms, that is 2000 ohms. So either you take it as 2000 ohms or you keep it as 2 ohms and do the calculation. While writing the answer, you include the kilo ohms. Okay, that is what I am going to do. So I take it as 2 ohms. Actually it should be 2000 ohms. I will do with 2 ohms and in the answer I will make it as 2 kilo ohms. Okay. So I am getting 16 ohms. So 16 divided by RC is 3. So 5.33. Actual answer should be 5.33 kilo ohms. Okay. Don't forget this kilo. So next we have to find RBC. So it is 8K and RCA it is 8K. Okay. So either take it as 2000 and do the calculation. It will be a bit tedious. So have written the answers and kilo ohms you add it. Now see this problem where you have to find the resistance between the terminals A and B. So you see here it is not easy to reduce the resistance here. So what we can do is we have to apply some star delta transformation to reduce the circuit and find the equivalent resistance between these terminals A and B. Let us start from this point. You see here 8, 6 and 4. They are connected in delta. So 8, 6, 4 are in delta. So first convert this delta into star. Okay. So always mark the terminals so that you will not do any mistake in conversion. Now let us convert this delta into star. So you have delta here, it should be converted into star, and when you have star connection you have a neutral point here. So if I want to find this, that's what I told, labeling is more important. I have labeled A, B, C, D. I have used small letters, but you can use anything, but always use labeling, that is more important. So to find this small RA, what I have to do, that is this resistance RA, I have to multiply 8 into 6 divided by sum of the resistance. That is a formula. So 8 into 6 divided by 18, sum of the resistance is 18. So you will get RA. Similarly RB, 8 into 4 divided by 18, and RC 6 into 4 divided by 18. So you got RA, RB and RC. Now this has to be included in this circuit. So this part RA will become in series with 4 ohms, and this RC will come in series with 8 ohms, and RB will be here. Now let us draw this equivalent star in the network. So 4 ohms will be in series with RA. So 4 and this one here, neutral point is here, RC is connected here and RB is here. So substitute all those values. Now you can see this 4 and 2.6 are in series, 8 and 1.3 are in series, and this parallel combination is in series with 1.77 ohms. So if you don't label it, you may change and write the answers. So instead of 2.66 here, you might write 1.77 and it will lead to a wrong answer. That is why I am telling again and again, always label it so that you can easily identify the values. So this we can add it. 4 plus 2 is 6.66 and 8 plus 1.3 is 9.33. This resistor remains same. Okay. Now these two are in parallel. So when two resistors are in parallel, we have formula R1 R2 divided by R1 plus R2. Okay. This is resistance formula, parallel resistance formula. So you multiply 6.66 into 9.33 divided by sum of that. So you will get 3.88. So your resistance is, parallel resistance is 3.88. So now all the resistance are in series. So when you have series resistance, add everything. So this is the answer, or the total resistance across the terminal A and B. This is how star delta transformation helps to reduce the circuit and find the equivalent resistance. So the points to remember here are, I have given both the formulas star to delta connection. So you remember, if you want to find RAB, RA, RB, RB, RC, RC, RA, add it divided by missing resistance. And if you want delta to star, you want this point, multiply these two divided by sum. So if you like the video, do subscribe to Read Electric Vehicle channel. Thank you.